In part 2, we're going to look at some more applications for time value of money. So let's talk about risk management. This client needs $700 per month in life insurance for a period of 25 years. If they can earn an interest rate of 8%, how much life insurance do they need? So the question is, she needs to receive, or this person needs to receive $700 a month. So under payment, you put $700, 12 for monthly, 8% is the interest, and again, 25 years. And if we look to the right, this person would need $90,695 in life insurance. So if they receive this, they could withdraw $700 a month for 25 years, and as long as they earned at least 8%, they would have get that $700 for all 25 years. We'd like to buy a disability policy that's going to pay $3,500 a month for 20 years. Again, if the interest rate's 7%, what's the value of that cash flow? How much disability insurance do we need? The annual interest rate 7%, 20 years, monthly payments. We're talking about receiving $3,500. Again, the solution is we need a policy that's worth $451,000 odd. You want to buy a car for $7,500. Going to put $1,500 down. The interest rate's 10.5% for 3 years. What are the monthly payments? So you put in negative $600 is the $6,000 is the loan amount. Interest is 10.5% for 3 years, 12 payments. The payment is $195.01. We also can use the loan analysis worksheet. Again, plugging here, $6,000 is the loan, 3 years, 12 payments, 10.5% is the interest. You see that there's $195 is the payment. The total amount that you'll pay over 36 payments is $7,020. So that means that the total financing cost is going to cost you $1,020 to borrow this $6,000. So what's the interest payment that's going to provide a $177 payment in the last problem? So if we know what we're going to borrow, $6,000, $177 is the payment, 3 years, 12 payments, we want to solve for the interest to get this present value of an annuity. So the answer is, that's roughly 3.95%. So as you can see, it's very mechanical to come up with the solutions. Identify the variables, plug them in, and look for the answer on the right-hand side. You have two salary options. You can get $50,000 a year for 3 years, or you can get a $25,000 salary for 3 years and get a $50,000 bonus today. Assume you have interest of 16% that's compounded quarterly. So which would you rather do? Well, 16% quarterly is an effective interest rate of 16.986%. So we want to use that as our interest rate to solve for these problems because it's going to be an annual basis, but we have interest that's actually compounding quarterly. So we put that, again, 16.986, it rounds it up here. That's the interest for 3 years, and you can get $50,000 a year for 3 years. So the value of that is $110,504. So that is salary option number 1. So essentially, that was going to earn you, in today's money, $110,000 odd. The other option is to get $25,000 a year for 3 years, which that ultimately turns out to be what? It's $55,252. But in addition to that, you get $50,000 today. So you add those together, that's $105,000. So which would you rather have? Would you rather have $110,000 in today's money or $105,000 in today's money? And of course, you'd rather do option 1 rather than option 2. You want to buy a house with a maximum payment of $630. You have 11.5% is the interest rate. You have $12,000 to put down. So what's the maximum amount that you would pay for the house? So you plug in the interest rate's 11.5%. It's a 30-year loan. Monthly payments. You would $630 is the amount, right? So you like to essentially you're going to be paying that out, or if you're gathering a loan, you would be receiving that amount. So the present value of $630,000 is $63,000. So now if you add the down payment to that, you'd be willing to buy a house with a maximum of $75,000. You'd like to save for your kids' college education. It's going to cost $24,000 a year for 4 years. The interest rate is 9.1%. Your son just turned 5, is going to go to college when he's 18. So what's the annual payment? And then obviously the monthly payment. So the current cost is $24,000. Inflation is 0. We're not including inflation here. Current age is 5. 18 is when he's going to go to college. He's going to be in college for 4 years. So you see here the cost, the 4-year cost, $24,000 a year. Investment return, 9.1%, what you expect to earn. So in lump sum, you're going to need $84,000 when he gets to college. So you can do that in an annual amount. It would be $3,633 a year or $285 a month. Again, this is the Education Needs Analysis Worksheet. Obviously, it's going to help us solve those kinds of questions. We can make complications. We can add inflation. We can also add current investment options. We can also add the possibility of not saving in a tax-deferred account, but saving in a taxable account. So all of those are options within this education planning strategy or worksheet here. You have a 10% coupon, 10-year bond that you paid $1,000 for. What's going to happen to the value if the interest rates in the economy changes to 12%? Well, in this case, we can actually use the bond valuation worksheet. You have $1,000, 10% is the coupon. The required return, we just said here, change to 12%. It's 10 years to maturity, compounding frequency 1. This bond is actually now worth $887. So you'd be, if you had purchased this bond for $1,000, which you did, you would now have something worth $887. So you obviously lost some value on this bond because interest rates in the economy increased. You purchased an asset for $5,000, it's now worth $8,000. Took 3 years for that to happen. What's the interest on, or the investment, the return on your investment? So you plug in what? It's currently worth $8,000. It started out as negative $5,000. That's the investment amount. Leave interest rate blank. Time in years is 3. So we end up with an interest rate that the return on this investment is around 16.96%. Again, as I kind of mentioned, this is a very mechanical process. You look at the numbers that you're given, plug those into the boxes, make sure you have all the information you need, obviously, and then look for the solution on the right-hand side. Due to a transaction, you're entitled to a $25,200 refund for each of the next 5 years. Assume you can invest at 9%. What's the future value of the invested refunds? So you're going to receive $25,200, and you're going to get that for the next 5 years. What's this going to be worth at the end of 5 years if you reinvest it all? Interest rate's 9%. Time in years is 5. You get 1 per year, so the compounding frequency is 1. And of course the payment, you're going to invest $25,200 a year. That's going to ultimately be worth $150,814 at the end of 5 years. Let's go to some retirement planning questions. You have 2 retirement options. You can take a $500,000 lump sum payment, or you can take a $5,000 monthly lifetime annuity. The assumptions we need is, first of all, we need to know life expectancy. You're 82, you're going to pass away when you're 82. The client's 65 years old, and the interest that you can earn is 8%. So what is the value of $5,000 a month for 17 years if you could earn 8%? And the value is $556,000. So which would you rather have? The lump sum payment of $500,000 or the present value of those $5,000 monthly payments of $556,000? I think obviously you would rather take the monthly lifetime payments rather than the lump sum. A client has the following dream. Client wants to take a traveling vacation. It's going to last 5 years, but that's not going to start for 30 years. After that vacation, he's going to want a retirement income of $30,000 a year for 15 years. And he wants to start depositing $5,000 per year starting today. So let's work through the steps. Question 1. How much money will the client have in 30 years? Well, if he invests $5,000 a year for 30 years at 9%, at the end of 30 years, he'd have $681,537. Well, he wants to have an annuity of $30,000 a year for 15 years, and again, interest rate's 9%. So the present value of that is going to cost $241,820 is what the retirement income is going to cost. So we need to find the present value of that $241,000 per year. When you solve for that, again, in 5 years, 9% is $157,166. Where does that number go? Well, we're going to have $687,000. $157,000 is what the retirement thing is going to cost. So that means he's going to have the remainder, $524,000, to spend on that 5-year vacation around the world. I think he could probably find a way to spend $100,000 a year over the time for that vacation. A couple more problems and then we'll be done with this chapter. Here's an estate planning question. You want to create a trust for the benefit of your husband. The trust is going to transfer to her husband in 30 years. She would like to transfer $1 million. If she can earn 8% annually, how much does she have to invest into the trust on a monthly basis? So the future value is $1 million. That's how much we want to put into the account, but we don't want to put it there for 30 years. The interest rate's 8%, and we're asking about payments for 12 payments per year. So if you go down below, to get this future value, we're going to make payments. Down below here, the future payments for future value of annuity, she would have to make $670.98 of payments every month for 30 years. That would accumulate to $1 million to be transferred into the trust.